All right, I might kick off today's session. So let me just give you a short bio on Jordan, who is our presenter today. Jordan specialises in capturing the post-disaster functions of critical infrastructure and translating them into practical resilience measures for natural hazards. He consults with government, engineers, architects and project delivery teams across Australia and New Zealand, and contributes to industry guidance through standards, technical societies, university research, and technical conferences. Jordan, feel free to add anything you want at this time. I'll just let everyone know that Jordan's happy to take any questions as the presentation goes. So if something comes to mind, you can raise your hand and go with that, or call it out, or put it in the chat function and we'll work through them at the end of the presentation. So over to you, Jordan. Thanks.
Thank you. Thank you very much. Today we'll be speaking to mission critical functions. So your business continuity advisor within your organization probably covers a range of elements up to a certain point. And this is kind of like that gap, looking for gaps between what the engineering side of the building, the design, the maintenance and so forth, and the business continuity expectations of the organization. So I'm speaking to you not as an engineer. I quit engineering, did a few other degrees, risk management, disaster risk reduction and sustainable development, and am presently studying to be a building certifier, coming from a different angle. I work alongside engineers, and we'll jump into it, hopefully. So yes, I run Proactive Design, and I also separately started an engineering company with Lachlan Darwin, that's Seismic Design Australia. So some of the elements that we'll talk about here are seismic design, but we'll be talking in a general sense about all non-structural systems and their exposure to hazard events. I am on the standards committee for 1170 Part 4, earthquake design in Australia, earthquake actions. I am a part of a range of societies, especially Engineers Australia societies, even though I'm not an engineer. But the opinions I'm sharing today are not those of those societies, but I am involved in a lot of their tech committees. I'm going to start with, you are running a hospital, you are supplying a hospital, you're designing a hospital. What are the community's expectations of facilities following a natural hazard event? So if we take a New Zealand example, which is relating to earthquake, and we do have earthquakes in Australia, and I'll not be addressing that heavily today, but they're expecting a protection of life safety as a priority. So avoiding mass casualty events, protecting vulnerable persons, safety in mass gathering areas, preserving high skills and resources. A lot of people actually leave town after a disaster. You get a brain drain of the area, immediate response, and maintaining the perception of safety. So I'm going to say to you, you don't have a limit. You have a limited budget. You're running a facility, you're providing things. There's a limited budget. You can't take all risk out of a facility, but you can have a vulnerability discussion up front. And I think these values here can be applied to all hazards, all natural hazards and disruptions. So I'm talking cyclones, bushfires, drought, floods, just to name a few. I will take a few out. I'm not talking about the extraterrestrial solar flares. I'm not talking about tsunami. There's not an appetite to be designing for these or to be considering these. There will be in some regions tsunami, but for the Australian context, this is not something that would get a lot of attention until we have one of those events. But in this scenario, I'm looking at all hazards as being a risk and looking at the exposure. I also have a different approach to some people. They may say, oh, look, it's a natural disaster. To me, it's not. It's a disaster risk. It's a disaster event beyond what we designed for. We've designed to a certain risk appetite, a serviceability limit. And so in that situation, we have said, we're not going to spend more than this. We're going to spend to a certain amount, what the code has said, and the code is based on what was considered reasonable by technical experts, but also balanced against the cost to society. So the question is, your agency, your organisation, what is your risk appetite? It might come down to the MP. The Minister for Parliament might not have a risk appetite in a certain region for flood, even though because he's experienced that before, where in another region it might not. So you can actually have differing bubbles around this country around different events, and people go, that's not a problem we have. But we try to look at all of these and find which ones we actually need to design for. There's also a reporting for the the Security of Critical Infrastructure Act to Home Affairs, which some organisations may have a specialist in-house that does that for their agency. You also may be tied to a state emergency management plan and have your agency may be having roles in coordination or response. So in South Australia, if we could give an example, the Department of Infrastructure and Transport has a responsibility for hazard risk reduction for earthquake. They also deliver all the infrastructure. So as a result, you actually get a matching of approaches where they've got the money and they're spending it, but they also have the risk reduction. So they actually have clear guidance documents to industry, where other states it's diluted across, oh, the certifier has a responsibility, or this agency and the builder and all these other people. If it's nobody's specific job, then in my opinion, no one's going to do it very well. But also you have a duty of care to vulnerable people. And I did a few AI searches for reasons to evacuate why Australian hospitals have been evacuated. And there was a myriad of natural hazard event related evacuations. Even could be just as basic as breaking of stormwater piping, or the sewer system backed up because the network backed up. So there's a range of things that can go wrong that if it hasn't happened in your neck of the woods, doesn't mean it can't happen. So when we design these infrastructure, we have a range of guidance for the importance level. Now, everyone's heard me probably talk about this in the past, but I just want to make clear, you're working from, is your hospital essential to post-disaster recovery? So if you're a private hospital that provides surgery, are you part of post-disaster? Well, you might have a state contract to provide emergency services to the public. Northern Beach has had this in New South Wales. Whereas you actually may be a building that may contain a large number of people, or you might actually be a hospital out in the middle of nowhere. And I'm saying nowhere in a cheeky way. You may be a very remote hospital, 500 kilometres away from the nearest primary hospital, but you get flooded in for 5 months of the year. So do you just lower that down to a 2 because you don't have a lot of people and you're not, well, we don't really have post-disaster recovery here because we're going to fly everyone out. That's not reasonable. So we have a bit more of a discussion. We go to the guide of the NCC. So medical emergency or surgery facilities is an IL4 post-disaster facility, but doesn't mean that you actually have to provide emergency surgery. It should actually have the word emergency in front of medical and surgery. So it should say emergency medical or surgery facilities for IL4, because a private hospital, again, may have an emergency department. They may have surgery. You can have day surgery, but it doesn't make the facility a post-disaster facility. So we're talking today about post-disaster, but I just want to make clear, you may not fit into that criteria. You may be a healthcare facility with a capacity of 50 or more residents. What's the definition of a resident? But not having surgery or emergency treatment facilities. So there's a bit of a mix here, and sometimes I get engaged simply to write a report stating whether the hospital, the new building that's being proposed, is post-disaster, or if it's IL3, or it can be downgraded to IL2. And this brings a cost to the structure, but also the non-structural elements. The design guide, the NCC does provide the design events. So if we're IL4, we've got a 2,000-year wind event. This actually has been updated. If you're in the region D of WA, you can actually have a 5,000 wind event, which is a few factors up on the design factors for wind, but it doesn't change earthquake. Earthquake's always 1500. I find engineers generally, structural engineers, don't work on IL4 very often. They over-design with the New Zealand values. And those New Zealand values are in section 3 of 1170 part 0, and they will result in over-design. And I find that 50% of the time I work on an IL4 project. If you are looking for determination, I have provided a few guides online in some of my papers, just to kind of assess yourselves and go, well, are we high priority to the area? Are there enough facilities that are designed like this within the area that might continue operations, or is there a low population density and no essential assets? You can end up in a range of different positions from this. But generally, the structural engineer just makes the call themselves on what that is, and they go to the section 3 of 1170 part 0. The mistake they're making is they're looking at the New Zealand section there. They should be looking at the NCC. The National Construction Code is the only guidance that's actually legal in Australia. 1170 part 0 is a mistake, but you will not be incorrect with some of the values that are used for IL2 and IL3. So you kind of get a bias confirmation that a structural engineer is doing it right up until they get to this IL4. I've spoken about these other elements. The facility also might be a safety case. You may have hydrogen, large amounts of hydrogen, or certain elements that make the facility dangerous to people, or it could be a nuclear medicine facility. So there's real considerations here about how resilient the facility should be, especially with natural hazards, because that can disrupt the facility, but also create an unsafe environment for the community surrounding it. So the only legal pathway that I have for an importance level 4 building is what's called an IL4 special study. The NCC calls up 1170 part 4 in total. This standard, the structural designs actions, I'm part of that committee. This is the 2007 version, and included in that was a statement. And I now have to move my camera to read it. A special study shall be carried out for importance level 4 structures to ensure they remain serviceable for immediate use following the design event associated with importance level 2. What it's stating here is, and the word serviceable has been changed in the 2024 version, which will be called up by the NCC 2025. They've changed the word serviceable to operational for immediate use. So in this scenario, when the importance level 2 structures, houses and so forth are falling down, the hospital should be able to maintain operations up to that level. We're not designing beyond that. We're designing beyond that from an ultimate point of view, but not for an operational consideration. From that, there's some great data that comes out of South Australia. Peter McBean, who was the director for the NRA, and I'll recognise there's a few people on this call that were involved in NRA. He wrote a paper in 2021 to give a process for this IL4 special study. McBean suggested that there should be a purpose and content and process, what the purpose and content and process should be, that there should be a role, a designated person to capture the special study requirements, and then to track it through the entire process to ensure that it's delivered, and it actually guides the business continuity of that facility for its lifetime, so that when anybody does any other works there, they have considerations around what's been achieved prior and what's to be maintained throughout the life of the building. And the South Australian government, if anyone's working in South Australia, they have a fantastic guide note, G205, which provides a bit of feedback for doing this IL4 assessment. This was published for the first time 2 years ago, I believe, and that gives you a process to follow. So I've summarised Peter McBean's process, and I follow this myself, and it's very close to the DIT document, to give you stages for stakeholder engagement, setting some performance objectives for the facility, translating those into design criteria for the design team, allowing a process for design response, so giving feedback, kind of checking yourself back against the stakeholder objectives and so forth. We already have review stages in design processes, but this kind of gives a clear capture of all data in one place here's the design criteria, and this is how the design will respond to this. In this stage, I also make clear what the agency who's going to occupy the building should be considering, because we can't design for all scenarios. We can't eliminate the risk at all times. We can't engineer for all risk. Some of them become administrative or PPE controls. And if some of the engineering elements fail, we need to have administrative controls. One of those might be evacuation, but we're stating at what stage that should occur, what the building design or the performance of that building should actually reach. In my opinion, the loss of control, you can do the most beautiful design in the world. The loss of control is at procurement. This is where somebody goes, oh, we were used in NRA. We're great, mate. We've got the right product for that. Just because you were used on a previous project does not mean that you will be adequate for the next project. Each facility is different. The design factors in the scenario will be different. The structural behavior will be different. This all needs to be verified. And this is where you end up with product. You end up walking through the project at the end going, why have you used this? Why'd you use this? Why is this installed like this? Oh, that's how we did it last time, mate. Is not the attitude. I have done a lot of hospital visits in the last 3 months, and I've been quite concerned about what I've seen. So in that, to back up the procurement, we're going to check everyone's homework. We're going to do construction monitoring. So we'll be doing checks, checking the install certificates and the design, that the original designs back here were actually installed here, and that somebody is signing it off. One of the best ways to do this is just state clearly at the start, I'm going to be checking your homework. You're going to need to provide certification and verification from the person who did the design. In this scenario, you're setting a clear outcome that people can choose to ignore, but I would not recommend it. Rework is very expensive. For the state, it's very embarrassing if you're not opening that facility on the due date. You don't want this to be a problem that's raised in the last part when it's found. You want to be finding this really early in the design phase. Even before people start, I usually give presentations to the subcontractors on what is going to be expected. And then it's the audit and documentation, so that the business continuity plan for the new facility is prepared as we go through. We're stating clear outcomes for them, for the agency who are going to move in there. We don't want them to be changing the place once they've gone through their own, they've moved in and realized things aren't working. You've also got the DLP process. They may not want to touch the hospital for a period of time because it's under warranty. You want it all done in the construction phase. So from my learnings, I find the best stakeholder engagement is actually who's chosen to be in that room. I want to hear from the director of nursing, the general director, and if it's an agency, a regional commander, somebody who has a knowledge of the area, maybe quite a bit older than other people. I want the head of engineering operations, somebody who keeps the wheels on other facilities and can already give me their regional climatic challenges that they've experienced. Quite often the procurement officer of the local hospital or security or safety officer might also have things for consideration that can be quite valuable. And the last one being the disaster or recovery managers of the agency. I'm going to be cheeky, they're usually in the dark. They're not part of the HHS. They may have somebody at the HHS, but they don't get involved in these design processes, and they have a great deal of knowledge from the entire hierarchy of that organisation. So I actually find them to be quite valuable. Yes, there are other people that will want to be involved, and I encourage that, but these are some of the baseline operations people that I think should be involved. Because what we're trying to set is some minimum business continuity objectives, which is across the bottom. That is a term used in business continuity. We're trying to establish what are those primary critical functions to be maintained during the onset of a disruptive event and maintained throughout the period. Now, if you have a morgue, that will be temperature control. If you have large equipment that can fail, that needs to be able to fail safely. So that might be a MRI magnet. You need all of the safety systems of that to continue operations. You don't want the UPS backup to be miles away in the building and able to have a failure between there and the machine in a emergency shutdown. You want to have gone through all of these failure scenarios and ensure that they are enforced. These are a risk to your facility. They could be ignition sources. They could be a source of gas, gassing off, or something else in the facility. What do we need to protect? What is going to threaten people? And what do people need during that event? Then we've got the essential functions to occur once we've done triage and ensured the place is safe to remain in. So what are we going to do for post-disaster function? I've got a discretionary here. You may have things that we may have tertiary, and then we may have quaternary. So you want to know which things we can actually stop in the facility. And I'll give you an example. So all of these elements here, we want to continue after a disruption. These ones we're going to stop. So if I had a rural hospital, I might want to bring renal dialysis back online within 24 hours. I might want the people who are already in the seats to continue getting their service, their life safety, continuing like quality service. But we may need to have a certain amount of water to finish those number of chairs, the number of services. But we might be able to put off renal dialysis for 24 hours. We won't start anymore. We may not need pathology for the next 24 hours. This was a very rural hospital. So in that situation, you don't have the staffing numbers. You may be very disrupted. People have other obligations, like checking on their own family or loved ones. So in that situation, just maintaining the critical functions and then preparing for essential may be very challenging. But bringing these back on may be of value. But we put a lot of other things off. So we'll design the load of the hospital to continue operations for a longer period, for say longer than a power outage, by continuing these services, what we require here. And I just want to say that natural hazards is a big basket. There are a range of other hazards. So I'm going to bring into this, we're looking at earthquake and wind because the National Construction Code requires us to. They also require us to consider rain and hail, but in ways you might not think of. Structurally, a hail event can actually be the greatest load that the roof of the hospital needs to accommodate. A rain event, the large rain events, may actually result in ponding on the roof that may actually enter into some of the vertical rises, or sometimes the actual facade may step up a bit higher because we want our buildings to look nice. But you can actually end up with greater ponding on the roof than the hail load, depending on the design. Flood and drought, we may need our hospital to be able to run in a drought event, in a prolonged drought event, and water supply may become short on a heat event day. So can we flick over to, have we got redundancy of systems so that we can actually run on low water usage? Extreme heat, these are increasing events. Bushfire may have an onflow to the air handling, but keeping charcoal filters around may not be adequate. They're very expensive. They clog up in a time frame, but they also need to be stored in a very special way. So all of these events is what I include in a special study. But your facility may have an ASIO overlay on it, and may need to consider blast, violence, and other forms of attack, kinetic attack. You also may have technology outages that you already need the services design team to design for, or dangerous goods. What the IL4 study does is it allows this team to set their own criteria, but it'll also capture that because it will affect, we can use that data to cover all of these events at the same time as this and work on what the worst case scenario is. For most facilities, I'm finding it's earthquake and power outage. If we're in the north of Queensland, it may be cyclone. When I say north of Queensland, of course, the events still hit non-cyclonic areas. The design event for Brisbane is still a non-cyclonic, but in that scenario, the earthquake accelerations for a tall building may be greater than the wind event. So we have governing factors, but it doesn't wipe out the need to, if the wind event for the structure is greater, it doesn't wipe out the earthquake design requirements for the non-structural. Because we're doing this now to remove, and this is the breakdown of the disaster management cycle over here into components. We're doing all of this now so that in the response and recovery stage, we're less affected. We're trying to set a limit so that we can maintain to a certain acceptable level of risk for the agency. And the design team doesn't need to go and make more changes, or we're not changing the facility later. Because the disruption tail is the worst thing. This is where this time drags out the more disruptive the event is to the facility. And that can mean lives, that can mean loss of samples. There could be, this has happened around the country, biological samples have been lost, whether it's something that is something that's going to be life-saving, or it also could be life-producing samples and so forth. These elements need protection, and the longer the duration of exposure, the greater risk there is. And an earthquake doesn't, of course, give you a warning, but other events do. So I'm just going to skip that one. When I talk about the length of time a facility can run, I'm talking about an island mode, a mode it can run off the infrastructure. But you can actually extend that. You may have fuel refuels. You may have a diesel being supplied to you. But the people who back you need to have a generator to run their pumps, to fill their truck, to come and fill your generator. And as was discussed at an IHEA event in the past, you also need a contractor whose staff are going to drive during what is a wind event, but not yet a cyclone. You need companies or suppliers with robust processes and the ability and confidence to actually deliver when you need it. And we can use the hierarchy of controls. So if we can't engineer something out, we'll go to the administrative or the PPE. We'll find other solutions, but we need to identify these early and not try and react at the time. We'd like to have some things in place that are reasonable. So here we have an engineering control, and here we have an administrative control. Elements that haven't been built into the facility, we will build in all the connection points. Sometimes people will say to me, oh, we don't actually have a way to receive water from a potable water supplier. That was not built into the design. This is a minor thing to implement at the time of putting in the tanks, and quite valuable. So from this process, we'll set up some reasonable expectations. This is the serviceability event. This is the structural, this is up to the structure's top performance. We're maintaining life safety. This is beyond the building code. This is where it becomes unsafe. And we're trying to set unrealistic expectations so that the business continuity is clear of what to expect in that facility, in that building. So we've gone through the stakeholder engagement. We've set some performance requirements, and then we're setting some expectations that are reasonable, so that we can then set performance objectives. Those times, what the serviceability events should be, what the limits are, and what the BCP expectations. And as an example here, we've got some generators which are going to operate for 48 hours of the operating load with 43,000 litres of diesel. In that situation, every generator will have 1,000 litres in their day tank, and then we have two external 20,000 in-ground tanks, which need to be pumped up to the rooftop. We put the generators on the roof there. This is the system. We can also bring in a mobile generator. Some hospitals need to work on certain areas that may need to cut the power between the generators and the road and the external infrastructure. So in that situation, having provision for a mobile generator is very important. You don't want the fumes to be blowing towards the hospital or the air intakes. You need to be able to put that on a level area. Allowing for that up front is quite important. And you need to have a transfer function for them from the mains to the generator supplies that are accessible or automated. But in this situation, the actual facility becomes responsible for ensuring that they've got delivery arrangements in place for the facility. Oops, sorry about that. So this facility, 48 hours and 72 hours under earthquake event. So we can, using the administrative controls, we can extend the length that the hospital could run on its own before the BCP has to be delivering fuel. And you do activate the BCP earlier. In this scenario, we then go into the performance requirements, and we state for each piece of equipment or each area of equipment, this is something on vibration mounts, we're going to have a higher design level of flexible connections to external elements to accommodate dynamic actions. These things are going to bounce around on springs. We need to allow that in the earthquake design. So there'll be a different factor for each one of these values. I've got to stop doing that. Then we move on to the construction process. Yes, the design evidence. Yes, there needs to be checks. And I've actually already covered this by accident, so I will move past this. But here's the hard part. It's matching the expectations of the organization and capturing those versus the function versus the budget. So in a scenario, I wouldn't suggest building a hospital anywhere near the 100-year flood level. I would be aiming to be above the 500-year adjusted for climate change level. And that way we're effectively eliminating the flood risk. But sometimes you may have already owned the property. It may be a political issue to move it somewhere else. So I do recognize there are challenges there. You may substitute the hazard. So we, instead of having drought, we go with air cooling as our redundancy for the water outage during a water outage. We may engineer we may use an all hazards design. So we're isolating people from the hazard. We probably need to add more to that, but creating a space, so separation of the risk from the people. Business continuity plans become your administrative controls. Putting masks on patients when you don't have negative air pressure may become your backup in the situation if they're breathing if you've got just trying to think about my pressures here. If you're probably trying to use positive pressure, this might be the lowest level you may go to, but that's not really the budget we'd like to work to here. And the Oz Health Facility guidelines should guide a lot of these elements. Because what we want is, in this process, we want to have in place business. We want to be able to adjust if we have advance notice. We want to have preemptive actions, or we want to know what they are. Under island mode, we want things to automate in an automatic fashion, continue operations, and only the primary functions. We may stop the secondary and tertiary functions until we've got through triage and until we get to the early recovery. So we may be checking on every person, and then we start to provide triage and providing help to the people before we get further support, which may take, for example, I believe it took 14 hours for the army to get to Bundaberg Hospital when Cyclone Marcia hit. So that was 14 hours, and they had 4 hours of diesel, was my understanding. Now, there was one diesel truck in town, which was full of diesel. So that went there, and a butcher was supplying food to the hospital because they had just-in-time delivery for food. And then it becomes a state and federal-led recovery when it's a larger event. And it can be a very long road for some areas. And I think some areas, if memory serves me, the emergency services in the town that got flooded, that's going to avoid me, starts with L, in northern New South Wales. I believe the emergency services are still operating out of the local university in that area because they cannot return to the lowlands where their facilities are. So what I want is the island mode to carry the facility through, and I would like to see assisted mode, these other services, to start extending the facility about halfway through its resources, because you don't want to have to run low. So example here, I'd like the diesel to run past into this area where it's starting to get refills, and I'd like that to continue maintaining operations long term. Because in my world, which is resilience, we've already got the structural engineers who are covering off the structural failure, but it's the non-structural elements that can create a risk to life safety from the fit out, from the non-structural elements being the building services, the walls, the ceilings, even just a sprinkler activation, which has happened during surgery, I believe, in another state. This sort of stuff should not be happening. We need to maintain our egress, and we need to continue business continuity. And we design this into our standards, into our tender documentation, our specifications. But there's a lot of areas that aren't delivered well. And sorry, this pink was showing previously as grey. Okay, it's changed with the format of the slides. Because we're getting down to here, we're letting building certifiers who have nearly no technical expertise. I'm sorry to say it. I'm studying this now and I'm a bit stunned, but no man can be the receptacle of all knowledge. In this scenario, these are not the people to verify all this, because we're going to end up with non-compliant operational facilities, and then one day they'll be tested. Now, the earthquake could be far away. It could be any type of wind event, like South Australia when it lost all of its power. What was great about that event was the Royal Adelaide Hospital was lit up like a Christmas tree when the rest of the city was in darkness, but it actually hadn't even been opened yet. It was still in commissioning phase, is my understanding, and it was a great test to illustrate that it did have the systems in place to handle disruption. Because then, the more prepared we are, the less we have good procedures in the facility, and I don't think we're ever going to get to early warning. I use this for New Zealand. They are working towards that. We have our new alert system, but it won't work for us. Won't be doing earthquake, because we want to avoid emergency repairs. We want to have adequate supplies, and we want to be serviceable for immediate use. We don't want to be reducing services heavily. We don't want delay, and we certainly don't want a period of disruption of the facility, because this will provide people with good operational support and less fatalities, is what would be illustrated by any research in this area. My main learnings is the organizational culture and politics is the greatest resistance to these processes. An organization needs to value stakeholder engagement in the process of looking at natural hazards. Now, South Australia is doing a great job here. It's mandated for the IL4 special study, but they've made it clear, and they also want to look at the other natural hazards. Getting the right people in the room is the key. I want an honest discussion about these performance, not dreams. Let's have something reasonable. Let's have an honest discussion about it, and not shut the topic down and say we'll be fine. We've got the best designers in the world. That's not the case always. And so we're looking at serviceability. It's not an ultimate event. We're looking at what the hospital is expected to do, and then we'll test it against the BCP. Let's check what is actually in the organisation's BCP. Calculations need sunlight. If you've got a clear calculation and statement about how long or how much water you're planning to use, the engineering department can go and look at that and just say, I think you've overdone it. I think you've undercooked it, and so forth. Good sunlight is a good disinfectant, I think was said by maybe Churchill. I like a bit of sunlight on the calcs. Earthquake is very misunderstood. There's a lot of contractors out there posting on LinkedIn their pride images about what they've done in hospitals, and I look at it and see defective work that I am addressing directly with Health Infrastructure Queensland, New South Wales Health Infrastructure, and so forth. There is not enough knowledge out there, and the IL4 special study provides a level of assurance in that area. Wind design is horrendous. I don't know if anyone's had anything fail at their hospital due to wind forces, and I'm talking about the non-structural here. This is being missed every day of the week, in my experience, and a lot of people assume that all of this is in the BCA, but it actually is engineering due diligence and not always turned into words in a standard. The facility needs to be buildable. We're trying not to set standard expectations that can't be met. The business case is where you lose control in the first place. It's great to just get the project ticked off, get going, and we'll deal with it all later. The loss of control is that point there, because when you get to the end of concept, schematic design, the budget is going to be the challenge at that point. It'd be good to have this conversation much earlier, but having this discussion, the best time to plant a tree was 20 years ago. Let's just plant one now if we haven't got a tree. Making clear the responsibilities, because it needs to be a level playing field at tender. Tender is, like I said about procurement, the loss of control is at tender, and you don't want to be educating a contractor mid-project. Test evidence. A lot of companies don't have good test evidence. Just a fire test is nice. It doesn't mean that the element meets the rest of the building code requirements. You need to meet them holistically, and there are a range of products that don't. And they're used throughout your hospitals, because I've seen them. There are multiple models of procurement. I've been highly impressed by some of them. Some of them, I think, have a lot of risk when you are allowing a lot of freedom and not giving a lot of contractual solids in the procurement. Monitoring, it's homework checking. And you might be a specialist in something, but it doesn't mean you have holistic knowledge. I've seen even New Zealand engineers who specialize in seismic design go and change a product, not recognizing they've just changed a fire safety system. So in that situation, they've rendered an element ineffective because it's never been tested. In verification of installation is very important. Yeah, it'd be good to have an IL4 consultant in your stress testing the facility, looking for elements that are vulnerable, just based upon the knowledge of the entire construction. So I'm involved in the entire design process, and if somebody else is not in that room and I've understood what they've said, the person can actually raise these concerns later and go, that was not the intent. It kind of is a continuity of the design team to a degree. And the BCP preparation doesn't start when you get the new facility. It should be moving with the design of the facility. So, in conclusion, I've loaded you up. Facilities of importance require a robust model. So this is for the asset owners and the agencies to consider, and I'm seeing some massive holes, especially on defence and health. Yeah, massive gaps going on. But everyone's an expert, and this is an unknown known. It's known to somebody because you're working under, say, SA Health, or you're working under HIQ, and they're now enforcing this on their projects. This is an unknown. If you're in health, you might be in New South Wales, or WA is a long way behind, in my opinion, and I'm sorry to say that. I have given notification to WA Health, though, so that they can review the situation. Hazardous facilities, you don't want your health facility to become a hazardous facility. Business continuity objectives, they require protection. Under the building code, it's a requirement, and in time the SOCHI Act will catch up. It does have a natural hazard section, but they are allowing self-assessment, and they're not actually giving guidance in that area on what that looks like. You should be embedding resilience to credible threats, and that includes earthquake and wind, which is a legal requirement. And what I'm finding from this process is you break up the silos and you break the assumptions. They get challenged throughout the process. And I feel, and everyone could be blowing smoke, that people are actually enjoying the process and the challenge, but also it's improving their thinking about other challenges. And resilience planning is a role in itself. If it's everyone's job, it's nobody's job. These are a lot of my publications, and I've got a few more coming in the next 3 months of presentations around the country. And I'm very happy to take questions. I don't see any, so I'll hand over to, I think it was Michael and Vanessa, to see if there's anything else.